Guys, this is Dr. Ben of Alpha College. I'm going to give you a demonstration on subcooling. Yeah? Subcooling on a refrigeration system. And you have to remember always to inspect your gauges. Inspect your gauges. And then make sure there are no cracks or breaks anywhere on the hoses. Now the needles on the gauges must be on 0, and that is very important, just to make sure the calibration is right. Yeah, right. And then you can attach your hoses. Yeah, blue to low side, red to the high side. Right. Now, as I've explained before, anytime you attach your gauges, you have to purge, because when you haven't attached the gauges, atmospheric air might have entered into the gauges, so you have to make sure you purge so that you don't contaminate the system. Now for the purging, that is not the lesson for today, so I'm not going to do that, but you have to crack the low side service valve so that you get gas coming out. Yeah, to the low side, it will go across across the low side in the manifold gauge to the high side, and then you can purge. And you purge at the high side. After purging, you can now turn the system on, because you've cleared all the moisture or the air that might have entered into the system. Right, now we can turn the system on and then you run it. Let's talk about subcooling now. After purging and everything, what is subcooling? Subcooling is done as part of what we call commissioning. When you install a unit, you have to commission it. As part of the commissioning, you have to do subcooling. We do pressure tests and all that for the commissioning, vac the system, and then you charge it or check the gas level. If you have to charge, you charge it. If you have to top it up, if not, then you carry on. But with subcooling, when you check your condenser might be maybe undersized or oversized. It's very important to confirm that. And then also you have to make sure your condenser is condensing. It is not over condensing or under condensing, but the condensation is normal. When you get normal condensation, then you are assured of an efficient operation, and that is very important for the customer. So for the subcooling, what we do is we check the difference between the temperature, the condensing temperature, and the temperature at the outlet of the liquid condenser. Yeah, the condensing temperature, you check it at the high side, which is normally, you look at the operating pressure on the high side, the recorded gauge pressure, and then you look at the corresponding temperature. Let's say the system is running, your pressure on the high side might be, let's say, 12 bar. Now that 12 bar, you look at the corresponding temperature for that. Now that corresponding temperature you get, that is what we call the condensing temperature. That's the temperature at which the refrigerant is condensing in the condenser. Even though the gauge is attached away from the condenser, what you record here is what is happening here. Most people don't understand when I explain that, because they think, how can this reflect what is happening in the condenser when you've attached your high side gauge on the liquid receiver? But that is what happens. That is why we said during condensation the temperature remains constant in the condenser, but the state of the refrigerant changes. And that is true, because when the system is running, you'll find that the high side pressure is stable. Yeah, in the beginning it will be fluctuating here and there, but it becomes stable as the system continues to run, and it doesn't move. And because it doesn't move, the temperature you get also remains the same. So therefore, we can confirm that during condensation in the condenser, there's no change in temperature. There's no change in temperature, but it's only the state that changes. Now, you have to have the thermometer. That's one of the instruments you need to have for this exercise. Your gauges, your thermometer, and you have your ratchet, for the service valve, and then you have your adjustable, for you to use